So, so first things first, we, in this particular module, we are working on learning about carbohydrates. So two things to remember. One thing is that, first of all, carbohydrates will have either a ketone or an aldehyde group in them. So this particular group, if it is in the end, where you have the C double bond O, which is also called a carbonyl. Let me write that down for you. A carbonyl functional group. So all of these, the unique groups are the functional groups. So this carbonyl group, and along with H, this forms the, aldehyde. So that is an example of one of the sugars. And similarly, you have ketones, but ketones are in the middle, so they don't need an H because they have 4 bonds because of being in the middle. If it was on the side, you need that additional H to make up the 4 bonds. So aldehyde or ketones, but with multiple alcohol or what we call hydroxy functional group, hydroxyl group. Okay, so I'm going to write that as well. This is called hydroxyl. So just getting used to of the terminology. So hydroxyl group, and the rest you can see are just the carbons and the hydrogens. So this is that we just need basics, okay? So anyone who is joining now, you haven't really missed anything. I just started. I'm talking about how sugars can be either having an aldehyde functional group or a ketone. And if it's an aldehyde, it's going to be at the end with a CHO. And if it is a ketone, it's going to be in the middle with the CO. Also, sugars are always having the name OSE. And glucose is a simple reminder. When you think of sugar, you're like sucrose, glucose. Okay, I know it ends with O's. So just a reminder, it's going to be easy if we kind of think of all the common examples. Okay. So when we are talking about this is a triose. So tri is for 3. So I hope that you are starting to get familiar that tri is 3, and then like that, if it's a penta, something is 5, hex, something is 6. I hope you're getting comfortable with that kind of terminology. Okay. And I know there are a lot of people in the class, but to ask questions, it's not, your question will help others too. So I hope you will not hesitate. So if you see here, the triose, tetros, pentos, hexos, and heptos are just like how you would learn in geometry: triangle, tetragon, pentagon, hexagon, heptagon. So just like that, it's just indicating the number, okay? So it's the same origin with the OSE indicating the sugar. And how do we decide D and L? So I'm going to come to that because that was one major question I'm going to address. But before that, I want to remind you that sugar can exist in 2 forms, long chain and ring. And even though you're not writing C here, this is C1, C2, C3, C4, C5. Very important, guys. Very, very important. The skeletal structure, that these ends are not meaning, don't have no meaning, is not true. They have a carbon on each corner that is not labeled with a molecule. So when it's not labeled, it's a carbon. So I want to bring you also to the chirality part, and I'm going to bring back to the anomeric as well. But let's first solve the chirality because that seems to be like more bothering everyone. So we're going to go with that first. So if you look at my pointer in here, you see this, you see these hands. And if you face your palm to the palm, so right hand palm to the palm, and you can try out now, it is an absolute mirror image because the palm will face the palm. The thumb will face the thumb. The first finger will face the first finger, and so on and so forth. Okay. And so all I mean to say is they are perfectly a mirror image. But the moment you try to lay your palm on top of this hand, which is actually called superimposition, if you see on the right side of the arrow, that's what they're trying to do. You can see that they are not getting superimposed. So that is what leads to the differences in handedness. And that's what we are going to learn as we go. So I'm going to avoid these two examples at this time, just to make it easy, but you will see what I mean when we come to this figure. Okay. So in this figure, that's exactly the hand example that we were talking about. I'm just talking about hand or similar things that you can see. These are not superimposable. Anything that is not superimposable is chiral. Okay. And anything that is superimposable is non-chiral or achiral. Non and a here have the same meaning. So let me write that down, is that achiral is same as non-chiral. Okay. So I know that this still doesn't help, because when you look at the molecules, it's really, really hard to imagine how this will translate to a molecule. So let me solve that problem for you for once and for all. Okay, how do you find out in terms of molecules? So if you look at this, this is our key to the success. So everyone needs to pay like 100% attention to this part. A carbon that has 4 different groups, as you see here, R1, R2, R3, R4, and I'll explain to you exactly what I mean by R1, R2, R3, and R4. A carbon that is attached to 4 different things is a chiral carbon. So it's something which is mirror image, but non-superimposable. And so it is called an enantiomer. So again, I'm going to say a carbon that is attached to 4 different groups is the one that is going to be chiral. Now, let me replace this. What I'm going to do is I'm going to do something. I'm going to replace this R, and I'm going to put a R1 in here. Okay. So now this is R1. For a minute, if you think this is R1, this is R1, this is R3 and R4. And similarly here, I will replace this with 1. So now this carbon is attached to 2 R1s. When it is attached to 2 same things out of 4, it is no longer a chiral molecule. Okay, I'm going to try to explain this to you with a very nice example, which is right on the next slide. So you don't have to think about your hand. You just look at a very simple thing. Is this carbon, which is shown here by this red circle, just to represent the center, is it attached to 4 different things? Well, let me see. It is attached to H here, which is different from CH2OH, which is different from OH, and which is different from CHO. Yes, I think I do see that it is attached to 4 different groups. Whenever it is attached to 4 different groups, I just call it chiral. I don't try to superimpose. I don't try to think anything more. I just see whether it is the exact same, it's meeting the definition. That means, is it attached to 2 different things? So essentially what I am telling to you is, if I was going to change this and have a O here, okay, let me see. It's a little bit hard, but I'm going to try to do this. Okay. Still not that great, but okay, I'm going to remove this altogether so that it's not confusing. And in this place, I'm going to put OH. So now I have a question for you. Okay, so you see what I did. I have removed the H from here as well. And I have simply replaced it with the OH. Oops. Sorry. Now, my question to you, are these 4 different groups? Of course, you can easily say no. I can totally see that 2 of them are exactly the same. So now my next question. Now with this new configuration, is this chiral or achiral?
Achiral.
Achiral, yes. So very simple. You see 4 different things, you declare it's chiral. You see even two same things, you call this achiral. I'm going to write this here just for now. So what I'm writing is 4 different groups is chiral. So we are not going to, again, stretch our mind too much and start thinking, how are we doing this? We are just going to see not all 4 are different. So we have now arrived at a very basic definition where we don't have to think too much when we do questions, when we see in the exam. We just see 4 different chiral, not different achiral.
Professor, I'm
Yes.
sorry. When we're looking at whether it's 4 different groups or 2 is the same, are we looking at both the left side and right combined together or separately?
Good question. Very nice question. Okay, so I will answer that by saying you don't have to look at the other one at all. I just was trying to show you an example that will help you. But no, if you said, do I have to look on to this side? I would say no, you don't have to look at this side at all.
Okay.
Just see one and you can declare whether it is chiral or achiral based on having 4 different functional groups or not.
Okay. And then another question, would this make it to the same if it's like how you have the CHO and then the HO, but that both the HOs are the same? Is that how you look at it?
I'm looking at it like this and this are same. You know
Okay.
what I'm saying? I'm
So it
looking,
doesn't.
yeah. So I am not, I'm just looking at, I looked at this. This is one. And then I was like, oh, this looks different. I'm trying to do in different colors just for it to help you. Then like, okay, this and this, they are the same.
Right.
The moment I see them same, I say they are achiral.
Okay, so it doesn't matter. So it's like if it's mirrored, it's okay. It doesn't have to be like HO.
Yeah, it doesn't have to be, or okay, I see another question. Let me, I see what you're saying. Yes, they don't have to be here. If HO and HO were here and here, even then.
Okay.
If here and here, then if they were here, it doesn't matter. You have to look if it is 1, 2, 3, 4. 4 different? Yes. Not all 4 are different. Achiral.
Okay, so if the other one was like CHO and then it was like OHC, that would technically still be 2 of the same.
Okay, so I mean, I see what you're saying. I mean, it is CHO, then it has to be like the same group, like it will bond the same way. I mean, if it is a O here, then it is a completely different compound, like it's a ether. You know what I'm saying?
Okay.
It's different. But let us see, let's look at more examples. Let's try to make this clear. Now, I want you all to think and tell me, why does it say there are 2 chiral centers?
Because it's 2 OHs and 2 H's too.
Because this particular carbon has 4 different things attached to it. Okay, number 1, which is H, number 2, which is CH2OH, number 3, which is OH, and number 4, that is C. I want to ask this everyone with respect to this carbon which is circled. Does everyone see the 4 different things that are attached to this carbon? Or you don't see? If you don't see, tell me, because I want to make sure that I show it to you.
Yes.
No, I don't see it.
You don't see it. Okay, great. So that's what I just want to make sure that we see. So we are talking about asymmetric carbon 2 here. So let's just work on this. Group 1 is H. Okay. Group 2 is OH, which is on the other side. Group 3 is C. So this C is attached to a C. We're just looking at that, the C with all of that jazz. That's different. So this doesn't look same as H. This doesn't look same as OH. Okay. And this is also attached to a CH2OH, which means that this carbon is attached to, I'm going to again go with different colors. Okay, so I'm thinking my hydrogen is red. So, well, I don't see any other hydrogen. I do see one hydroxyl, OH is hydroxyl group. I do see one CH2OH, which is another group. And then I see, then I see this one. So I circled for you 4 different colors with the thin circles, not the thick one. You see how those 4 things are different from each other.
Right. Yes.
Okay, if you see that, now I'm going to ask you if this particular C, do you think this also has 4 different groups, like, which I mean, like, you know, this is your one group, this is another. Now we are looking at this particular C. This is another, and I have one more here. So I'm trying to see if I can, this is another. So sorry, this is like, didn't quite hit the blue color. So you see this particular C, which we are in, which I'm just going to color for now, just for you to see. This particular C, which is in blue color, like a ball, it is attached to 4 different things. One is group H, which is shown here. The other is group 2OH, which is shown on the right side. One is group C, which is shown on the bottom with all of that. And the other is group 4, which is CHO, which is shown on the top. These 4 are different. So this is another what we call asymmetric carbon, a carbon attached to 4 different things. Once you see an asymmetric carbon, you immediately say that it is chiral. Okay, I want to pause here because I want to give you the time to absorb the concept and ask me back if you have any questions. Sometimes it's just hard to see. And trust me, if you ask one more time, it doesn't hurt anyone's, you know, and it only helps people in understanding.
So, Professor, quick question. So we don't need to worry about their image to be superimposable or non-superimposable, right? Just looking
Great
at
question.
how many.
Yes, great question. And that is actually, you are providing now the answer to what everyone has to ask. Absolutely correct. We don't have to look at their images. That's a concept that you need to understand, but we don't have to look at their images. All you need to look is it an asymmetric carbon or not? That's all. Does the order matter? Not really. No, the order doesn't matter. I do want to tell you one more thing, but only after I have no other questions about chiral, achiral. So 2 asymmetric carbons, and those 2 asymmetric carbon mean that there are 2 chiral centers. But one more thing here is we're going to look at the last asymmetric carbon always. So, you know, again, when you are naming this, you may be thinking, I'm not so sure what is a D and an L form because I see so many OH, what am I going to do? Always look at the last asymmetric carbon. That is going to be your key to understanding D or L form. If the hydroxy is on the right side, you call it D. And you may say, why is this called D? You know, it's just because they're Latin names. So dextro is right and levo is left. So D is for right on the OH and L is for left on the OH. So that's why it's called D erythrose and L erythrose. Similarly, if you look here, this is on the left side, L triose, and this is on the right side, that's D triose. Let's look at another example. Okay, so these are called the D and L form. They are also called enantiomers. That is the fancy name for this DL pair. They are called enantiomers. And if they look kind of same, but they're not same because the arrangements are different, then you call it diastereomers. So I know it feels like a lot, but I think if you go through it one more time, you should be fine because this is like the second time we're going and then you do the assignment, it will make sense if you kind of go back to the PowerPoint. So let's look at one more example. And I'm going to take you here. Okay. So in this one, ribose. So let's make this a little bit crazy. How many, we are looking at this particular molecule. How many asymmetric centers are here?
Three.
3.
Any other thoughts on this?
4.
Okay, yeah, I mean, it has three centers. And the reason why I am saying that is because it is this, this, and this. So now this won't count really because this is C double bond O. So I mean, we don't really take that into consideration. And this won't count because CH2. So it has already 2H, you know. I mean, if you were to really write down the CH2OH, you know, it's going to look like a little different. It's going to look like H with the C, sorry, H with the C with the OH, and then CH2. So it's going to actually look like one more down. And then, so I mean, the CH2OH, I mean, this won't work because there are 2 hydrogens in here. So that's what we are thinking when you're thinking of this. So this has truly 3 asymmetric carbons. And I'm just going to mark them with the circle. So this is your 1 asymmetric carbon. This is 2nd asymmetric carbon. And this is 3rd asymmetric carbon. Okay, and once you look at this, you look only at the bottom one to see, only this last one to see where is OH. If it is on your left hand side, you call it L form. If it is on your right hand side, you call it the D form. I know this can be confusing, so feel free to ask me any questions about this.
And you call this the asymmetrical carbon?
Yes, it's asymmetric as long as it has, absolutely, as long as it has 4 different things attached to it, it is asymmetric. So the ones that are circled here, I can actually circle them in the blue. So these blue circles are nothing, but they represent 3 different asymmetric carbons. And you can actually write them down. I actually encourage you to write these things down. The more you write, the more you will be confident. There are 2 ways of doing it. One is like, I got this, let me move on. The other is, can I do it by drawing with my own hand? So the more you will practice, the more it'll get easier. So in this one, there is, I'm going to just do it just one to show to you. So this one has a OH, 1 H, they are different. 1 CH2OH, that's different. And this C attached to all of that thing. Well, those 4 are all different. What about this carbon? This carbon is attached to one of this, which is actually this whole big thing. So it's not like as simply as you may think, oh, this is attached to C, this is attached to C. Is that how it is? No. This is attached to C with all of that. This is attached to C with all of that. They're different because that has a double bond OH. And one of the hydrogens and the other is hydroxy. So I can see that there is 1, 2, 3, and 4. Attached to 4 different things. So every time I go, I check the things around the carbon and say, okay, these 4 are different. So this is going to be definitely an asymmetric carbon. And now let me ask you, is this a chiral molecule? What do you think?
Yeah.
Yeah,
Yes.
if it is asymmetric, then it is going to be, yes, absolutely. Yeah. So the other thing I wanted to talk about was, again, the D and the L form, because they can get confusing. I just want to remind you again that there may be many OH. You see here, this is a mess. There is 1 OH here, 1 is here, 1 is here, and this 2 are here, 1 is here. Don't get caught up in this. Please look only at the last asymmetric carbon. So I'm going to circle that for you just to emphasize what I mean for you, the last asymmetric carbon. I'm just going to look at this. I'm not going to let myself get confused. If someone says, is this a D form or an L form? I'm not going to be looking at all of that. I'm going to look at last carbon and say, this is on the left side. This is an L form. Done. Okay. So again, for L or D form, no, and for chirality, no images needs to be formed, but you need to understand the concept. And so that is why that was being stated. Now, one more thing which people get confused and often make mistakes in exams. So I'm just going to go back to that, and that will be the anomeric carbon. Let me make this clear because I already saw at least some mistakes in one or two assignments here and there. Okay, so just please, I hope you can, you are focused for this one. Anomeric carbon is a carbon that is attached to two oxygen. This is not that hard. Whenever you see a carbon, see what are the bonds it forms with H, with O, with O. The moment you see two oxygen, you call it anomeric carbon. When you see two oxygen, if they are in opposite to each other, it's alpha. If they are towards each other, it's beta. And when it's towards each other, how I remember is I just think they're same side, and I can actually make a beta with them. So, okay, so beta is always on the same side and alpha is on the opposite side. So beta and alpha glucose is not same as L and D forms. So again, we want to have a clarity here. Alpha and beta are coming from anomeric. L and D are coming from the position of OH. So that is what we need to understand here. Okay, so, in this one, this is alpha, and then you have the D as this is on the right side. Okay, so alpha D glucopyranose, pyran is for 6-member ring, and beta D glucopyranose. So you can see there alpha and beta forms are coming just because of the position of the O's. What I was observing is that people were very tempted to put this C, like, I can see an actual carbon in this, so it has to be anomeric carbon. No, I just want to remind you, carbon is here, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and that's carbon 6. These are the 6 carbons that are present in the glucose or the glucose ring structure, which is also called the Howard projection. Any questions from anomeric carbon and alpha and beta forms? And if it is hard, then I don't mind explaining it one more time.
Yeah, can you explain it one more time? I'm sorry.
No problem. No, you don't have to be sorry ever, I'm here. That's what I'm here for. I just want to tell you that these were actually carbons when you made them a ring. So it's not like you need to learn. I would never ask you in the exam how to make this ring. But you have to remember, even if it is a ring, first of all, this is a carbon. It's called carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. Now, what is an anomeric carbon? Anomeric carbon is a special type of carbon that is attached to 2 oxygen. Now, let us try to pretend that we don't know. So this carbon has 2 H and 1 OH. So it cannot be this. Okay. This particular carbon is attached to 1 oxygen. Yay. Is there another oxygen? No, I don't see another oxygen because it's attached to a carbon, a hydrogen, and hydrogen. It cannot be this one. This carbon is attached to a hydrogen, oxygen. Okay, we found at least 1 oxygen, but no more oxygen. So it cannot be this. Similarly, not this. Similarly, not this. But look at this carbon. This is attached to 1 hydrogen, 1 carbon, but 2 oxygens. So this is oxygen 1, oxygen 2. So a carbon that is attached to 2 oxygen is called an anomeric carbon. And it can exist in 2 forms. Either this H is on the top and OH is on the bottom, or flip it. OH is on the top and H is on the bottom. So that means it is still attached to 2 different carbons. So this form in which they are opposite to each other it's called alpha, okay? They're kind of against each other. In the B form, they are on the same side, okay? So I'm going to be, I was trying to draw a figure to show you, this is how you draw beta, right? Beta is almost looking like a B. So if you think of a beta, then, if you think of a beta, then a B would go like this, 1, 2. So you can see that a beta structure, both the things are on the top, and alpha is against or opposite to each other. So this is how we remember the alpha and beta form. Alpha and beta form have nothing to do with L and D forms. Okay, we can always see here, and I don't want to confuse you, but at the same time I want to draw your attention to this one. The OH is on the right side, so let me circle that. So we do know that this is going to be a D-glucose, because right is for dextro and dextro is for the hydroxyl being on the right side. So it's a D-glucose, but it could be an alpha or against each other, or beta or towards the same side. So that is why this nomenclature, alpha D-glucose and beta D-glucose.
So pretty much the only difference is gonna be on the OH, right? One is gonna be up and the other one is gonna be down.
Absolutely, or opposite to each other. Let's just say that, sometimes these rings are switched in the sense that instead of being straight, the O could be down. So as long as you see they're towards the same side, that is your beta. If you see them opposite to each other, that is alpha. But good question. Okay, so that's the second thing I just wanted to explain, the anomeric carbon, because when you start doing the assignment, it can get confusing and you may think, I'm not even sure. And the biggest mistake people can make is not think that these are not carbons. You can see this is carbon 1, carbon 2, carbon 3. You can see they're labeled like that. So whenever you see a skeletal structure at the points of skeletal structure is the carbon. So the other thing is, I told you today, and I hope it is clear now, that whenever you have to decide chirality, you just see a simple thing. This R1, R2, R3, R4 are nothing but 4 different types of groups. If there are 4 different types of groups, you call it chiral. If these are similar, and even 2, 3, of course, so I mean, if it is more than 2 also, it's going to be achiral. So minimum 2 is achiral, 3 same groups is achiral, all the 4 are same, like in methane, of course it's achiral. Okay, and they are also called enantiomers. So just, I know it feels like, oh my gosh, why does this have so many different names? But just like you will go ahead and learn a lot more about dental hygiene, and then you will realize, oh, I guess I really needed that terminology. It's like that. The chemists do need that enantiomer terminology to learn. So, that's why this comes in here.
I have a question.
Yes, my dear.
If there are more than one carbon, but only one of them is attached to 4 different groups, will that be chiral or not?
That is chiral. It has 1 chiral center.
Okay.
As you can see, there are 4 carbons here, but 2 are chiral and there are 2 are not. So it is still, it has 2 asymmetric and it is a chiral molecule.
Okay.
And like I told you, diastereomers are a little bit different because they are not mirror images. You can see the OH and OH, like, I mean, you can't form a mirror image, but I mean, if you went to write the formula, they look the same. It's going to be CH2O, CH2O. This is CH2O, but they are just opposite. So these are diastereomers. One more thing that I wanted to cover, and I felt like people were a little bit confused, and I thought that I should have actually explained it better, is towards this reaction side. So I'm going to go to the reaction side, but we can come back if needed. So all the sugars, first of all, you need to know that all the sugars are D, the ones that we use, and our body only uses D sugars. It cannot use L sugar. Okay, so so we talk about reducing, reducing sugar and non-reducing sugar. So how do we test it. So the way we test it is, the way we test it is by using what we call as the Benedict solution. So in this one, the sugar gets reduced and the copper gets oxidized. And the oxidation of copper makes it brick red in color, and that's what changes it. That's what makes that copper turn from blue to red. So that is one more thing, the oxidation and reduction. But we still need to do one more thing, which was confusing people. And again, if you look here, now let us look at this glycosidic bond very, very carefully. In this one, first of all, I need, I want you to notice that in this one, the arrangement of this is opposite. This is an alpha arrangement, and this is a beta. In alpha, like I explained to you, this is it goes from, it is opposite to each other. And in this one, it is on the same side, okay? So, it is alpha, and, this one is beta. Now, I do know this can get a little bit, confusing, but I hope that you do realize that we are on two different ends. And this bonding, COC bonding, is called a glycosidic bond. I want you to see how this bond can be like this or like that. It's going to look a little bit different. So it can be like this or like that. Okay. And why am I mentioning that to you? I'm mentioning that to you because we're going to talk about how the glycosidic bond is formed. That will help you to do the last question of your assignment number 2. So I know that there were a lot of questions on assignment number 2. The last question of assignment number 2, when people individually approached me, and those kind of questions really helped me in realizing what needs to be added or what you need help with. So if you see here, I'm going to explain to you with this figure, which I'm going to add and update the PowerPoint right after you're done, is I'm going to talk about hydrolysis and dehydration reactions now, okay? So let's first look at the bottom one, actually, the dehydration synthesis. You are familiar with the glucose molecule. One glucose molecule added to another glucose molecule. What will happen is how that makes maltose is water goes away and they combine to form a glycosidic bond. Going away of water is called dehydration. Some of you may argue and say, water is right there. It didn't quite go away. Well, it kind of went away from the molecule. So my argument for that one is that it has gone away from the molecule and gone away. That is why I'm calling it, this is dehydration. So if you don't drink water, what happens? You get dehydrated. So the molecule just got a little bit dehydrated because the water went away from maltose. But what you have gained is instead of 2 glucose molecules, you have 1 maltose molecule. This means that you're forming a dimer and releasing a water. That means it's a synthesis. Synthesis means making something. You're making a dimer, releasing water. That's dehydration. In hydrolysis reaction, exactly the opposite will happen. So we're going to focus now on the top part of the figure. So we have maltose in here, and you have the maltose is to be broken now. So, you want to use the energy, you need the glucose. So how do you do that? You actually add water to maltose. When you add the water, hydrolysis. So in this one, hydro means water and lysis or lysis is the breaking. So it's breaking with water. So you're breaking maltose with water. So once you add that, you will get 1 glucose molecule and another glucose molecule. So you've broken the maltose to get 2 glucose molecule. That is hydrolysis reaction. So this is going to be really helpful for you when you are going to do your assignment question, because that particular question is based on actually the previous slide. When you break this, what do you get? And in that, it says specifically show your work. Okay. So it's not like if you don't show your work, you won't get any points. You always have partial points. But if you draw these, then you get those additional points. So once I add this slide, it will help you to finish that if you have found it difficult so far. Okay. I also want to say that the reason for me to ask you to do that question is because throughout the entire assignment, there is no question that asks you to draw a cyclic glucose ring. Of course, naturally, you wouldn't be drawing these structures. The assignment, and in the exam, I would never expect you to draw a glucose molecule. I would not do that. But for you to be able to have complete understanding and confidence on the topic, if you actually even do it by seeing, it's going to help you in getting that confidence. I think I completely understand this particular reaction. And if for any reason you don't, we can always get back to it. So does anyone have any questions about the last question of the assignment?
Yes, Professor.
Yes, Adia.
So are we expected to draw the cyclic structure for the 2 questions?
Yes, the products at least, even if you don't do the substrate. By substrate, I mean on the left side, what I've given to you, and products is on the right side. So whatever is the fill in the blanks, if you draw those, because there is a lot of space below that, I would really appreciate that. And you will get full points for that.
Okay.
Anything else about that particular question or anything in the assignment at this time?
Can we clarify number 4, please?
Number 4, okay. I have to actually go back and try to see what number 4 is. So give me one moment, because I kind of prepared myself based on what I was looking in the comments. And for anyone that I have not responded to your, if I have not responded to your email, please know that my intent was to respond, but at the same time, not confuse you. Suppose I explained you something over email and it confused you, then I would never want that. Okay. Okay, so number 4, I see. I can take you to number 4, even though we are not going to do it together because you're going to do it by yourself. And I'll give you enough hints to help you do that. So I think you meant this one. Okay. So all you need to do is count the number of carbon, hydrogen, and oxygen and write it here. Okay. So if you think there are 6 carbons, you're going to write there C6 and then H watt and then O watt. So it just helps you think and realize how different or similar these molecules are from each other. That's all you need to do. Okay. Is there anything? Sorry, go ahead, Valerie.
I think that's where I get confused. For the C, just for example, we have for the first one, 1, 2, 3, 4, 5. Do we still count the one on top? It will be 6 or no? Oh, okay.
Yes.
I feel like I was counting. I wasn't worried if it's a new one after it becomes like a whole with the other ones, or no?
Yes. You have to count all of them similarly. O, even as O is here or here, or
okay,
or there or there or there, and you will actually find something real fun once you do that. That's the purpose of giving this, that you will count and you'll be like, wow.
May I ask another silly question?
Yes, please. No question is silly question. Ask me.
The H2 well, it comes like 2, right?
Yes, that's not at all a silly question. That's a great question. Let's at least look at this in that way. So this has
there is some C's that have a 2 on the bottom. So I was wondering, will that still count as a 2 C's?
Yes.
Okay.
So these are 2H. This is 1H. This is 1. This is 1 here, 1 here, 1 here,
Okay,
1
thank
here.
you. I think many people will have the same question than I did. That's what I was kind of.
Yeah. And you know, it is something that you would I mean, it's, for me it may sound obvious, but for you it may not. It's like, you see, I'm not good at baking and you may be great at baking, and you told me a recipe but you didn't tell me to butter the pan before or oil the pan before you put it. As you'll be like, wasn't that obvious? As like, I've never done that before. So it helps to ask those simple things, and I don't mind at all clarifying. So I am going to go to the top of the assignment, and if you feel like that helps you in asking anything, you can ask now. So if you see here, we just went over this. We went over what is chiral and what is achiral. So I'm not going to discuss this assignment, but I'm going to hope that you are going to now look at it carefully and do it. Also, the L and D forms. We talked that L and D forms are not complicated because you have to focus only on the last carbon, last asymmetric carbon of the molecule. We talked about Fisher and Howard projection. I think I've not written the name properly here. Take a look at these structures. So we just talked about this one, alpha and beta forms. We talked also briefly about that. And
I
then
have a
finally,
for number 5, we're supposed to draw the whole ring, right?
yes, you are supposed to draw an exactly identical ring except for that beta, whatever that difference is.
Okay, thank you.
Yeah, yeah. And again, the purpose is just for you to get more and more familiar with this. You will not be asked in any exam where you do not have, where I don't expect you to have access to notes to draw this. So this is something for understanding. Also, you should know what are mono and disaccharides and polysaccharides. It's something, those are quick. So these are the things that will tremendously help you in quiz, because in quiz, if you were going to go back and look at things, you will run out of time. The best way is if you know all of this, and especially if you are comfortable with these questions today, then you will be comfortable with doing the quiz and assignment both. So I'm going to stop sharing, but I want to ask if there are any other questions that you have. Anything specific that you can think of? And this is a very open office hour, which means that if you feel confident and you feel like you are, you have gotten answers to your questions, you are free to go and enjoy the rest of your Sunday. And if you have any questions, you're free to stay back and ask more questions.
Yes, Professor.
Mm-hmm.
When Valerie was asking you about the CH2,
Mm-hmm.
and so you said that the 2 means that it's 2 carbons and 2 hydrogens. Is that correct?
CH2 has one C. Let me see. Let me put this here. Let me make sure I explain this properly. So if when you have CH, I'm sorry, I have caps lock on. CH with a
2.
2 right here. Okay. So we have CH2 in here. So it actually means, I'm going to write here, it means there is C is 1 and H is 2. That means,
Oh, so the 2 is referring to the element that is right behind.
yes.
Okay. I thought it was
Yeah.
referring to the C as well, but it's only okay. I see.
And if it said C6 H12 O6, I know that those should be subscript. Then it actually means that there are 6 carbons.
Right.
There are 12 hydrogens and
Okay.
6
I
oxygen.
Okay. Okay, yeah, because I was thinking that it was referring to the carbon as well, but it's only referring to the hydrogen because the hydrogen precedes the number.
Yes, I can see the confusion, but so you can see here, if I say whatever the number is after, or if it doesn't have any number, it doesn't mean 0, it means 1. So suppose nothing given, then it means that it is just one carbon.
Okay, right. I remember you saying that before. Okay.
Yeah, no problem. So I wanted to tell one more thing about the exam is that what you are going to, I forgot to tell a little bit earlier, I meant to tell, is that you will see like there is like a poll, like a quick poll, which will allow you to pick a time slot. It's going to be a very quick 10-15 minute time slot. And it is going to be like we are discussing right now. The only thing is it will say in the beginning, of that announcement that I expect your camera to be on at that time, okay? Just to make sure that we are having a good one-on-one interaction. It's going to be very simple, just like I'm talking now, I'll be talking then. It's not going to be any different. I'm going to show you a molecule and say, hey, do you think this is an L form or a D form? Or what do you think? Is this a alcohol or what is this kind of thing? Can you name this molecule? So something very simple and very similar to what have been done in the assignment. Or look at this structure. Do you know which one is anomeric carbon? Do you think this is an alpha glucose or a beta glucose? Or look at this particular molecule. Is it a monosaccharide or a disaccharide? So, pretty simple questions like that.
About the exam, it's gonna be on a Friday, I see it, right?
So the exam, yeah, so about the exam, like the timing wise. So since the oral exam is, for you, it's going to be 10 minutes. For me, it's going to be 10 times or 15 times 25 students. So it's going to be something I'll spread over the week. So there are sometimes evening slots available where I'll be like, there's only a 15-minute time slot. So my earnest request to you, if you put down a time, please remember and come on that.
Right. When is the poll gonna be available?
Just today itself, I'm posting the poll. Okay.
Oh.
So you just take the poll, you put down the time. I'll assure you that your time is going to be only your time. And once you complete that particular, that 10 minutes, it should be done in 10 minutes, but I mean, maybe there are 15 minutes because, people just need sometimes extra time. And then we will be done and you can finish the rest of your exam because there are 2 parts to the exam. The exam will be due in 2 weeks from now, which means that after the next week, once you finish your assignment 2, we will be ready to do the exam 1, which is based on module 1 and module 2. So 2 modules. Okay. And so if you want, you can even though next week is scheduled for module 3, but if you want, and if I see a lot of requests about module 1 and module 2, I can push that back and just focus on any kind of questions or any kind of anything related to that you have. And I will also say that the other exam, it will be posted and you have like plenty of time. You will have like that whole week, but I always want to give a bonus in the exam, which means that if you submit your exam on 2 days before, okay? 3 days before, if you submit the exam on Thursday as opposed to Sunday, then you get 5 bonus points for each exam, okay? So there were students in past who always wanted to do the exam by Thursday because you do have a Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, you do have a lot of time. So if you are one of those students who want to finish early and get a 5 bonus points, you can do that. And some people occasionally end up getting more than what the exam is. Exam is 30 points and they end up getting 31 or 32. That's fine. And if you want to finish it on time and you are a student that needs that extra time, take your time, no points being taken away, but please finish it by 2 weeks from now, which is the next Sunday.
The exam is gonna be half oral, half computer, right?
Say that again.
So the exam is gonna be oral, right?
Oral, there are 2 parts. One is oral, one is written.
Okay.
So oral part is only carrying 1 set of points. I'll have to check how much. I think it's, if I remember, it's oral is either 15 or 20 points and the rest of it is 30 points. So it's a total 50-point exam. And you are given plenty of time because, in past I have done the exam. So I know typically how much students take. So you will know. And the exam is always set up in such a way that no 2 people get the same set of questions. So what I mean is it's from a question bank. So everything is very similar. It's not like it is more difficult for one versus another, but it is going to be something. It's going to be something that you can do very easily. So don't be worried. Do what you can. And if you said oral exam, it's going to be only 4 questions going to be there. and I'll walk you through the question. It's not, won't feel like an interrogation kind of thing. It's going to be more like you just having a discussion. Okay.
Okay. Thank
I
you.
request you not to be scared, because the past experiences I have, what I would say, which were much more like me getting to know you and helping you and telling you, hey, you know, maybe you should focus on this part or that part, rather than, you know, I mean, trying to get like too worried about it. So please don't be worried, and we can do it. And actually, I started having extra sessions. If you noticed, on Friday, I sent you an email, a text and announcement that on Friday I was with some students. We were able to get some things done. And I mean, if that, like that, if there are some times when you want to meet with me, we can meet and get more done. Okay. So I plan to be here for some more time, because I know that some people might have individual questions, but if you have no questions, the time is right around 3:30, and you can go if you want to. Okay. Any other questions from anyone? All right, everyone, enjoy your Sunday. And I'm still here. I'll be here about 10-15 minutes more, so that if you have any questions, you don't feel like you have to leave. Okay.
Okay. Have a good evening.
All right, you too, Paris.
Answer.
Yes.
Bye.
Okay, bye then. Any of you have any individual questions or problems with any assignment, you can just let me know. Any question from you, Lakada, Teresa, or Omobolande? I hope I said that right.
Yes, I was wondering, is there a separate website that I can go to try to learn more about this, or like maybe a YouTube channel or anything?
Yes, so I posted, did you look at all the resources on the module?